the problems based on tutorial class based on the inner product space, Hilbert space and the corresponding functionals defined on the Hilbert spaces. So, let us take the first problem, very basic problem. We know the norm on an inner product will always satisfy the equality that is known as the program law. So, norm on the inner product, on an inner product space satisfy the important parallelogram equality, satisfy parallelogram equality, that is norm of x plus y whole square plus norm of x minus y whole square is 2 times norm of x square plus norm of y square, clear, and that is what. Now, from here if a norm does not satisfy this parallelogram equality, it means it cannot be derived from the inner product. For example, the CAB which we have seen that this CAB does not satisfy this program law, that therefore, it is not a cannot be derived from the inner. So, similar type problems here is the problem is let X be the vector space of all ordered pairs of complex numbers The question is, can be obtained the norm defined on X by the expression norm X is mod x I 1 plus mod x I 2, where the x is x I 1, x I 2, this belongs to capital X from an inner product. This is the question. Okay. The solution is, okay. Let us see whether it satisfies the inner product or not. This norm satisfies the parallelogram law or not in equality. So, what is our x is x I 1, x I 2 and let y be our eta 1, eta 2, then both are in y. So, x plus y will be x I 1 eta 1, x I 2 eta 2 and x minus y will also be like this and they will also be the point of x. Okay. Now, the norm of x plus y, this is defined in this fashion, mod of first term plus mod of second term. Similarly, the norm of x minus y whole square is defined as mod of first term plus mod of second term. Well, whole square, it is not whole square, norm of this. Okay. So, and norm of y from here is defined as mod of eta 1 plus mod of eta 2. Now, if we substitute these values in the expression 1 a, then we see immediately this square will be this square plus this square plus 2 times this. So, as soon as you remove this square, you get less than equal to sign. Okay. So, this cannot be equal to the 2 times of norm of x plus square plus norm. So, obviously, it is easy to verify that equation A is not satisfied. Is it clear or not? One can easily follow. So, answer is no. Clear? That is the one. Okay. Is it clear? No. You just expand it and that. Because even if you square, you are not able to get this equality sign, and then both things will come. Now, another thing, we know the Pythagoras. If in case of the real, if the triangle is right angle triangle, then the sides, this is the x, this is y. So, this side length is norm x, this side length is norm y, and this side length is norm of x plus y. Pythagorean theorem says the square of this is the same as sum of the square of these two sides. In fact, this can be immediately proved with the help of the concept of the inner product. So, the question is, if x is perpendicular to y, okay, in an inner product space x, this is a generalized formation, generalized thing for the Pythagoras, then norm of x plus y whole square equal to norm of x square plus norm of y square. Okay. And this can be extended to the n mutually orthogonal vectors, because these two vectors extend by orthogonal two vectors, and one can do. In fact, the solution is very simple. Just you, if we go for the solution, what you do is start with the left hand side, norm of x plus y whole square. So, this can be written as x plus y, and one can easily obtain as x comma x, x comma y plus y comma x plus y comma y. Now, since x is perpendicular to y, so inner product of x y as well as inner product by x will be 0. Therefore, from here you are getting norm of x square plus norm of y square as others part is 0. Is it okay? So, there is nothing to prove. Now, the interesting problem is, if x is real, that is real vector space, then so that conversely the given relation implies, so that converse also holds good. That is, norm of x plus y whole square equal to norm x square plus norm y square is given, then it will imply that x will be orthogonal to y. That is, norm of x plus y whole square equal to norm x square plus norm y square will imply x is orthogonal to y, if x is real. The reason is because if we use this one expansion from here, norm of x plus y square is given from here. So, let us take this expression as a. So, if we look from a, what you get will imply the inner product of x y plus inner product of y x is 0. Is it not? Because this is norm x square, this is norm y square, and what norm of x plus y whole square is given to be this. So, this sum must be 0. But this is the same as x y plus the conjugate of x y is 0, but since the x space is real, so inner product will be same as this. So, this will be the same as 2 times inner product x y is 0, that is inner product of x y is 0. So, this implies x is orthogonal to y. Okay. So, in case of the real, this 2, but if x is complex, if x is complex, then this may not hold, then converse may not hold good. Why? Because the region is from A, if I take, then what you get it is inner product of x by plus inner product of by x is 0, and that implies inner product of x by plus inner product of x by conjugate is 0, and that gives the 2 times real part of the inner product x by is 0. It means real part of the inner product x by is 0 does not mean the inner product x by is 0, because complex part may not be 0. So, this will not show the x is orthogonal to by, clear. So, complex part may not be 0, therefore, the x may not be perpendicular to by, okay. That is why reason is, okay. Now, this okay. If an inner product is x is real, so that norm x plus norm y implies the inner product is 0. What does mean by this? Okay. In the similarly, if same problem, if I am continuing the same problem, if x is an inner product, real inner product space, inner product space, okay, then so that the condition norm of x equal to norm of y equal implies the inner product of x plus y comma x minus y is 0. And what is the geometrical significance of this, and what does this mean geometrically? If x is R2, okay, what does it mean by this? So, solution is simple, because this is given. So, what is that? Start with this norm inner product of x by comma x minus y. This can be written as x x plus inner product of by x, then minus inner product of x by, and then minus inner product of by y, is it not? And this will be, since it is real, x is real. So, basically these two will be identical. So, this is the same as inner product of x by. So, we are getting this cancel here, this is equal to this. So, total value is coming to be 0. Okay. Now, what does it mean geometrically? If I take this is our square, when this is the length is norm x, this length is norm y. So, square both are equal. It means x plus y vector is this, x minus y vector is this, is it not? The inner product of these two vector is 0, and that is obvious. It means the diagonal of a square are at right angle to each other, is it not? So, this shows the diagonal are at 90 degree. So, that is geometrical. Okay, that is what. Okay. Then let us come to,
So is it true for higher dimension also?
in case of the rearrange. Okay, that's, if your inner product this is okay, this we have 9. Achha, there are these cases I do not know with this. Once you know the inner product, norm is obtained with the help of the inner product, then we can also find out the corresponding inner product with the help of the norm, and that identity is known as the polarization identity. Okay, that we have discussed. So, this is no point of okay. Let us take this problem. Question is, what is the norm x in the, if x is this one? Okay. What is norm of x in this in L2 if x is xi1 xi2 xin where xin is 2 to the power minus n by 2. You know the L2 norm?
Yes, sir.
The L2 norm in case of L2,
Then x is equal to x1 x2 up to xn and it is finished.
no, up to
Acha.
infinite, infinite term. Okay. So, in L2 norm, if x is xi1, xi2 and so on, y is eta 1, eta 2 and so on, then inner product of x y is defined as sigma xi eta I is 1 to infinity and conjugate of this xi eta y, and when it is finite dimensional, then you say simply and I equal to 1 to n, is it not? Norm is L2. Okay. Now, here xi is given to be this. So, what will be the corresponding here inner and norm of x square is the inner product of x x, is it not? So, here x is given xi1 is given to be this. So, conjugate of this will be the same as this because it is a real. So, what you are getting is norm of x square is the inner product of x x, that is sigma of xi eta I. So, xi is 2 to the power minus n by 2 into 2 to the power minus n by 2, n is 0 to infinity, because conjugate of this is the same as this. So, this will be equal to sigma 0 to infinity 2 to the power minus n, and that will be equal to what? Sigma 1 upon 2n 0 to infinity, a geometric series whose sum will be 1 over 1 minus half. It means this is nothing but the 2. So, this will be equal to 2. So, what is norm x? Is under root 2. Okay. Therefore, norm of x will be clear. Just apply the definition, get this. Okay. Then we get
Sir, in the definition we have I is equal to 1 to infinity. Then we have to
it's no problem. I equal to 0 to infinity, karo, I equal to 1 to infinity, it makes no sense. If you take n is equal to 1 to infinity, then what the difference will come here? 1 to infinity, here it will come half and then 1 minus half. So, total value will come out to be 1. That is all.
so then the norm will be
1.
1.
That is all, 1. So, here it will be 1. It depends on from where you are taking. Okay. So, if it is 1 to infinity, then it will be half. That is correct. Clear? So, a over 1 minus half and 1 minus, so 1. So, it is okay. Clear? So, this way. So, this will be now this question, if x is a finite dimensional vector space and E j is a basis, E j is a basis for x, then so that an inner product on x is completely determined by its value gamma j k, which is equal to inner product of E j E k. Can we choose such scalars choose such scalars, can we choose such scalars gamma j k in a complete arbitrary fashion, completely arbitrary fashion, arbitrary fashion. X is a finite dimensional vector space and E j is a basis for X. So that the inner product on X is completely determined by its value this. Okay. Now, X is finite dimensional vector space. So, any element of this, if X belongs to capital X, it can be expressed, X can be expressed in the form of alpha I is 1 to n, clear. Now, where alpha 1, alpha 2, alpha n are suitably chosen, so that you get X. Now, since this is inner product also, in an inner product, X is also inner product. So, we can take X E j. If I calculate this X E j, then what you get is this is equal to sigma I equal to 1 to n alpha I inner product of E I E j. Okay.
We will get only the alpha I from here.
This is alpha. Okay. So, what you get from here is that this alpha I can be obtained
From this inner product of this.
from inner product if these are the basis element and orthogonal complement. So, we can get the corresponding basis for this. Okay. So, we can find out the alpha I in terms of the basis elements. Now, this alpha I is nothing but the gamma j I, you can find out. So, each element X we can find out in terms of the gamma j I. Now, this, it means this can be determined with the help of gamma j I. Okay. Now, this is not the answer. So, answer is yes. Okay, first case. The second case, the answer is no. Why? Why it's no? Because what is our gamma j k? Gamma j k is E j E k. Now, this will be same as E k E j conjugate inner product, but this is basically what? Gamma k j conjugate. It means we can choose that type of gamma only whose gamma j k is the same as the conjugate of the gamma k j. We cannot choose arbitrarily the constants. This condition must be satisfied. Gamma j k must be equal to gamma bar k j. Otherwise, we cannot. So, that is why the answer is no. Okay. So, that is clear. Okay. Come to another question. What is the Schwarz inequality in R 2 or R 3? Can you tell me what is the Schwarz inequality in R 2 or R 3? Okay.
You can start from the basic definition of Schwarz inequality.
Yes. So, Schwarz inequality is, what is the Schwarz inequality?
Inner product of x comma y.
Schwarz inequality says modulus of the inner product x y is less than equal to norm of x square, norm of x into norm of y. This is the Schwarz inequality. Now, in case of R 2, the inner product x y is nothing but the dot product of this. This is the dot product, and we know this dot product x dot y is mod x mod y cosine of theta. Is it not? So, we can say the modulus of the inner product x y is less than equal to modulus of this, which is less than equal to mod x into mod y. Is it okay or not? So, because mod cos theta will be less bounded by 1. So, that is why. So, in case of the R 2, the inner product Schwarz inequality is nothing but the dot product mod of dot x y is less than equal to mod x plus mod y. Okay, that is what. Okay. Then let us take this.
Sir, here in case of R2 it is very R2 or R3 is very simple to find out some type of theta in angle. In higher dimension we can define the angle from the Schwarz inequality.
No, we can define the what we can do for the higher order, find out the dot product, divide by length of the vector x and length of the vector y, that you will get the cos theta.
Miss, I want to say that in that means non inner product of x comma y, that x is some higher dimension, y is some higher dimension, divided by norm x, norm y.
Yes, length of x
less than 1.
Yes, no, it will be the cosine theta. It will remain less than or equal to 1.
Less than or equal to 1. Means we can define it is some type of the function of either cos theta or sin theta. So from that we can find out the angle.
Okay, so that the sequence xn, this, so that for a sequence xn in an inner product space, the conditions norm xn goes to norm x and inner product xn x goes to the inner product xx implies xn goes to x. Okay. So, let us see. It is given that norm of the length xn goes to norm of x and inner product xn x goes to xx, then you have to prove xn converges to x in the, of course, the norm defined by the inner product. So, what we do is we consider this thing, norm of xn minus x. Okay. Let us take the square. So, what you get is okay. Then you write this thing is equal to inner product of xn comma xn, then minus inner product of xn x minus inner product of xn xn, and then plus inner product of xx. Is it not? That is what we go for this. Achha, now this is nothing but the norm xn square. This is nothing but the norm x square. Okay. And this will remain as it is, let it be. Okay. Now, it is given that xn x goes to xx. So, as n tends to infinity, this will go to norm x square, is it not? This will go to xx, this will go to xx, and this will be same as norm x square. So, will it not go to 0? Sorry, is it not? Because this is norm x square, this is x n x, and this is norm. Now, as n tends to infinity, this will go to the norm x square. Then x n x goes to x x because of this condition. This goes to, so basically this 2 x square minus 2 times of the inner product x is the 2 x square. So, both will go to 0. It means when n tends to infinity, this x n converges to x in the norm defined by the inner. So, this shows the truth. Therefore, x n goes to x in the norm. Okay. Then, okay. So, that in an inner product space, so that in an inner product space, x is orthogonal to y if and only if we have x plus norm of x plus alpha y equal to norm of x minus alpha y for all scalars, alpha. Okay, this is it okay? Now let us see the solution. Let us given x is orthogonal to y. Okay, x is orthogonal to y. Now we want to show this result. So consider and given, okay, nice, given this, okay, we wanted to show this is equal to this. Okay, so consider norm of x plus alpha y whole square. This is equal to what? And this will be equal to x x plus x alpha y plus alpha y x plus alpha y alpha y. Okay. Now this is equal to what? Norm x square plus alpha conjugate x y plus alpha times y x plus alpha alpha conjugate, so mod alpha square norm y square. Okay. Now if x is orthogonal to y, then this inner product will be 0, this inner. So we get this equal to norm of x square plus mod alpha square norm y square. Okay. Now if similarly we can go for this, what is the difference will come here? If I open it from here, you will get first term norm x square, there is no problem. Only thing difference come here, minus alpha y, okay, and then you will get somewhere here also minus alpha 1 minus alpha. So that will be positive. So only there will not be difference, only the difference will come here with the minus sign. That's all. But no, x y is perpendicular, so this will go to 0, this will go to 0. In fact, what you are getting is minus alpha wall minus alpha plus mod alpha square. Okay. But x is orthogonal to y given, therefore, this is equal to okay. So both are equal, therefore, this implies okay. Clear? Now let us see the converse part, because if and only part is there. If this is equal, it means these two things are equal. Okay, then we have to show yes. Okay, so basically when you equate these two, so these two gets cancelled. Only thing you are getting the alpha bar plus of this thing. So conversely, what you are getting is okay. Conversely, given norm of x plus alpha y equal to norm of x minus alpha y, is it not? So square of this, and that will lead to the 2 times alpha bar inner product of x y plus 2 times of alpha inner product of y x is 0. Okay. Now if 2 is gets cancelled, okay. Now this is given to be x be any inner product space, for this we can find, okay, x be any inner product. So suppose I take alpha to be 1, okay, what you get? You are getting inner product of x y plus inner product of y x is 0. Okay. If alpha is equal to I, then what you get it? Minus I inner product of x y plus I inner product of y x is 0. That is, from here if I add I minus I gets cancelled. So, basically what you are getting inner product of y x is 0, that is x is orthogonal to y. Okay, that is what, clear, that is what. Or otherwise also we can say, because this is the conjugate of this, this is the conjugate of this. Okay. So, 2 times the real part of this will be 0. If alpha is constant real, then basically the inner product is coming, which is 0. So, inner product means x is perpendicular to y. So, that is why you are getting. Okay. Now, this will also leads one another problem, that is, so that in an inner product space, x is orthogonal to y if and only if norm of x plus alpha y is greater than equal to norm of x for all scalars alpha. Now, this immediately comes from here. What is this solution? Norm of x plus y alpha whole square is nothing but this. Now, whether alpha is complex or real, mod alpha square will be a real quantity, positive quantity. So, this will always be greater than equal to norm x square. Okay. So, basically it follows, solution follows from above. Is it okay or not? Need not to bother about it. Okay. Okay. Now, this 0 operator we have already discussed. So, need not to go for this. Now, this another problem. Let H be a Hilbert space. H be a Hilbert space. M is a subset of H. M is a subset of H, a convex subset. Convex subset. Okay. Then, and x n is a sequence in M. Sequence in M such that norm of x n goes to D, where D is the infimum of norm x when x belongs to M. X belongs to M. Now, so that x n converges, sequence x n converges in H. Okay. Now, let me, what is this is H be a Hilbert space, which is a complete inner product space. M is a subset of H, a convex subset, and x n is a Cauchy, is a sequence in M, such that norm of x n goes to D, where D is the infimum of norm x. Then, so that x n converges in H. So, how to prove this? We know every Cauchy sequence, if a space is complete, the definition is every Cauchy sequence must be convergent. So, if I prove that x n is a Cauchy in H, and since H is a Hilbert space, it must be a complete space. So, our aim is to show only the Cauchiness of this x n. So, let us start with this Cauchiness, and we get from here is okay. So, let us take, so what we do is we will show that x n is Cauchy in H, and since H is complete, inner product space, so x n will be convergent. Is it not? This is our trick. So, for the Cauchy-Nash, start with this. Cauchy-Nash means difference between any two arbitrary terms of the sequence must be go to 0 when n m sufficiently large. So, consider norm of x n minus x m whole square. Okay. Now, here I use parallelogram law. What is the parallelogram identity? Norm of x plus y whole square plus norm of x minus y whole square is 2 times norm of x square plus norm of y square. So, use this identity. So, this will be equal to 2 times norm of x n square, 2 times norm of x m square, and then minus times norm of x n plus x m whole square. Is it okay or not? Okay. Now, this will be what is given is now, okay, this one is given norm of x n goes to d, where d is the infimum of norm x. It means d, if it is infimum of norm x, then d must be less than equal to norm x for any x, because it is the infimum value. Okay. So, let us take this. The norm of x n will go to d, this will go to d, is it not? And this will be, what is this norm of x n plus x m? Well, will it go? So, this is less than equal, this is sorry, this will go to d square. Let us take, like I will put the sign later on, 2 d square, then plus 2 d square, okay. And then this part x n plus x m, this thing we can write like this: norm of x n plus x m is less than equal to norm of x n plus norm of x m. Okay. So, minus times of this will be greater than equal to minus times of this. So, minus of this is greater than equal to minus times, is it not? This, okay. Let us see this part. Okay. This is correct. Now, this part, this is equal to, this is greater than equal to, now x n converges to d. So, it is minus 2 d. So, if we take the square both side, then what happen is this square norm of this, you do not put it minus sign right now, you just take this plus less than equal to and then square, okay. Otherwise, it will be problem. So, we get x n plus x m, norm of this square is less than equal to 4 d square. Now, you put the minus sign, okay. So, you are getting this from here is, this is minus 4 d square, but this is exactly, yeah. So, it is the minus 4 d square, okay, minus 4 d square. Why it is less than equal to is coming? Will it be less than equal to or not, or greater than?
Sir, if this is means x m plus x n, this value is less than equal to 4d, then the minus of d will be greater than equal to.
No, what is this is, what I did is, parallelogram law I have used. So, parallelogram law says x plus y whole square, x minus y whole square is 2 times norm x square plus norm y square. So, I have put it the norm of x n plus y, oh, that is what I am mistaking. This is x n minus x m will be equal to what? Square will be 2 times this plus 2 times this minus this. So, here I have to put, yes, this is okay, minus of this, and then I used again norm of this square, because this goes to d, this goes to d. So, you are taking this norm of this and norm of this, okay, and this converges to d. So, this converges to 4 d square. So, minus of this, don't, I think don't go for this without even going for this x n and x n, okay. So, this is 2 d, 2 d means 4 d square. So, minus of 4 d square, okay. So, we get this is greater than equal to, in fact this one 0, okay, this is 0, is it not? Because this will be 0. Once it is 0 means you are getting xn and xm, they are very close to each other after certain stage. So, we say xn sequence is a Cauchy sequence. Should be greater than equal to, because here is minus sign, but why minus is not, if I put it equal to greater than equal to, then this will be automatically greater than 0. So, it is less than equal to this part, minus this is okay. So, it is a Cauchy sequence. Okay. So, what we see here, that we are getting this thing as 2 times of this minus 4d square, 2 times of this 2 times minus 4d square and less than equal to. Okay. So, we get, so this once it is Cauchy sequence, therefore, x n is convergent. So, let us see. Then next is, let x belongs to R 2, x norm of x n goes to d, d is the infimum of this. Okay. So, it is okay. Okay. Let x belongs to R 2, the x is equal to R 2, find m, orthogonal if m is a the singleton set x, singleton set x, where x is xi1 xi2.
Sir, I think that sign should be greater than equal to. That sign must be greater than equal to.
This one, na?
Here.
Because of this minus sign, so minus is greater. So, if you get the greater than equal to sign, then this is 0.
Sir, basically, sir, norm of xn plus xn always less than equal to 4d square. If we put 4d square, it indicates that we are subtracting something more. Hence, the left hand side will be somewhat higher.
So, it is greater than equal to this, greater than equal to 0. Okay. So, this will be x n minus x m will go to 0 after a certain stage. Okay. That will be greater. So, we get. Now, x is find m perpendicular if m is x, where the x is x 1 x 2, which is not equal to 0. Let us see what is the m perpendicular.
The set of all values is perpendicular to the set of m.
M perpendicular is the set of those vector v belongs to R 2 such that inner product of x v is 0, where x is a element of M. Is it not? Now, M is this set, M is a set x, xi1 xi2, which is in R 2. So, what is the inner product here R 2?
Inner product of
R 2.
x1
Inner product in R 2, is x y is equal to what? x1 xi1, if x is xi1 xi2, y is eta 1 eta 2, then inner product will be xi1 eta 1 bar plus, but because it is real, so this inner product will be xi1 eta 1 plus xi2 eta 2 as real. Okay. Now, this we want it to be 0. So, it means what we want is the xi1 y xi2 must be of the form minus eta 2 by eta 1. It means even if I reverse the order, then it will be helpful. Suppose xi 2 I put it, xi eta 1 I put it to xi 2 and eta 2 is minus xi 1, then it will be 0. So, we can take like this xi 2 minus xi 1, this is the point if I choose, then this will satisfy. Is it not? This will satisfy. So, that will be the point in M perpendicular. Clear? So, that's okay. So, that will be the point. Okay. Now, okay. Next, in case of this continuity, okay. What is it if EK is an orthonormal sequence, is an orthonormal sequence in an inner product space X, in an inner product space X, and X belongs to capital X, then so that x minus by with by given by sigma alpha k e k, k is of course 1 to infinity, okay, where alpha k is the inner product x e k, x e k is orthogonal to the subspace y n, which is the span of E 1, E 2, E n. Let us see what is this. Is x 1 is this. So, how to get it?
Sir, basically what we have to find that is an orthonormal sequence, and this is some compound for the x minus y, y given by this
E k is a orthonormal sequence and x be any element of this, so that x minus y with by given by this is orthogonal to the subspace by n. Okay. So, first thing is what is by? The by is the linear combination of E k. So, by belongs to the span of E 1, E 2, E n, that is the elements of by n. Is it not? Which one infinite? Is it what 1 to n? Sorry, this is 1 to n. 1 to n. Okay, it's a span of this. Now, any element x, if I take x, can be written as by plus x minus by. This by is an element of by n, and this x minus by, according to that projection theorem, we can express any element x as a direct sum of the by and by perpendicular. So, basically this will imply that x minus by must be orthogonal to this by n, that is must be orthogonal to E m, is it not? And that can be seen from here, that can be because what is the inner product of x minus by E m? This is the inner product of x comma E m minus by comma E m. Okay. Now, x comma E m is nothing but what? X minus by minus E m. If I take by, this is the linear combination. When you take the inner product with E m, it is E alpha m only. So, we are getting is alpha m, okay, and this alpha m x E m minus alpha m, when you take x E m minus alpha m, then what is x? X is this element. So, inner product of this will be 0. Okay. So, we get so that x minus y given by this orthogonal to this space. Why it is coming to be x e m minus alpha m is 0. What is alpha m? Alpha m is this x e m. So, basically this is also alpha m, is it not? And this is also alpha m. So, we are getting 0. So, this shows x minus y is orthogonal to E m. So, if it is orthogonal to E m means it is orthogonal to y, because it is a linear combination. So, it is okay. Thank you. So, okay, thanks.